Today on The Explainer, we're going to break down what gas pressure really is.
It seems so simple, but it's actually trillions of invisible collisions every second.
Okay, to really get this, we're going to use a simplified model, the ideal gas. So picture this, a perfect box filled with zillions of tiny particles, all bouncing around. To understand the whole crowd, let's just focus on one single molecule first. Okay, so here's our little molecule cruising along, heading straight for that wall. Bam! It hits the wall and bounces right back, a perfect elastic collision. And that little kick it gives the wall, that's it. That's the source of the force. It's got to go all the way to the other side and back before it hits again. Put that all together, and this is the average force from just that one particle.
Right, but one molecule's force is tiny. What happens when we add all the others?
Yeah, their movements are totally chaotic, but add them all up and something predictable happens. This equation gives us the total force. That VRMS is basically their average speed. So it's not just about total force, it's about how concentrated it is. That's pressure. And voila, here's our main equation for the pressure of an ideal gas.
So this formula actually gives us 3 levers we can pull to control the pressure.
More molecules, higher temperature, or a smaller space all ramp up the pressure. Simple as that. But can we simplify this even more? Is there a deeper connection hidden in here? This is where it gets really cool. Let's compare our pressure formula to kinetic energy.
Whoa, look at that. They're almost the same formula, just a different fraction out front.
So pressure is literally just 2/3 of the kinetic energy in a given volume. Meaning, what you feel as pressure is just the combined motion energy of all those molecules. Which leaves you with a question, right? What happens at absolute zero? Something to ponder.